Hello again. In this session, we will study motion under gravity. So, the reason why we are separately studying motion under gravity is because whenever something falls or moves freely under the influence of gravity, it has a constant acceleration. A constant acceleration which is denoted by the symbol g and is called the acceleration due to gravity. This acceleration has a value of 9.8 meter per second square and is often approximated as 10 meter per second square. So the significance of this value is that no matter how large or small the mass of a body, it will always have this acceleration if it is falling under the influence of gravity. Now when we say falling under the influence of gravity, what we mean is that there is no other force acting on that object other than the gravitational pull of Earth. Right? So now, since we know that the acceleration is constant, we can apply the three equations of motion that we had studied. Because if you recall, we had said that these equations are valid if and only if the acceleration is constant. Right. So these are the three equations of motion which we can use in case of gravity. Right. So let's look at a few cases and see how we can do that. So the first case, we see that an object is thrown upwards. So if you throw something upwards, you know it goes up to a certain height and then falls back to its original position. Right? So this is the point from where the ball starts, goes to a certain height and then falls back to its original position. We are interested in finding out the time taken by this ball to fall back to its original position. Right. So once again, first let's try to identify the known variables. In this case, what do you think is known? At the first sight, it might seem that we don't have any information. But let's look closely. First of all, we know that once the ball is in the air, there is no other force acting on this ball, with no other force other than gravity. And we know that the gravitational force will cause the ball to move with an acceleration of 10 meter per second square. Let's first use the general symbol g. Right? So this ball has an acceleration which is equal to the acceleration due to gravity. So first of all, we know acceleration. What else can we tell? Think about it. If the ball starts from this point, goes up to a certain point and then returns, what can we say about its displacement? If you think about it, the ball has not moved from its position in this entire interval. It did move, but it has finally come back to the same position. Hence, the displacement of this ball is zero. Right? Because it has finally come to the same point from where it started. And hence, its displacement is zero. Right? Next comes sign convention. We know these are vector equations, and while substituting values, we must substitute them with sign. So, for sign convention, let's take upwards as positive. Let me remind you once again that it is completely up to you whether you want to take upwards or downwards as positive. But you only have to make sure that you stay consistent with your assumptions. Right? So now, when you do that, let's focus on the acceleration. Upwards direction is positive, and where does gravity pull? It pulls down, right? So this acceleration is downwards, and hence it will have a negative value. Right? Now, in this case, it is additionally given, it should be given to you the initial speed with which the ball was thrown up. So you're given the initial speed with which we have thrown the ball, because clearly the amount of time it takes would depend with what speed you throw it upwards. The higher the speed, the greater the time taken, right? So we know the initial speed as u. Also, it is thrown upwards, hence this would be positive. So once again, these are the set of parameters we know or are to be found. So let's think of an equation which can help us find this. Clearly, the second equation would do the trick for us, right? So let's use the second equation, which is S is equal to ut plus at square by 2. Substituting values, you see that S is equal to 0, u is plus u into t. In place of a, we will substitute minus g, so this equation becomes minus gt square by 2. Now the further simplification is simple. I'm sure you can do it by yourself. One of the t can be taken out common and it goes to the left hand side and becomes 0. Hence you see that t turns out to be 2u by g. So this time that we have found is basically the time that the ball would take to go upwards and then come back to its original position. So what does this mean? This means that if from the ground you throw a ball upwards with a speed of 10 meters per second, then it would come back to its original position after a time of 2 into 10 by 10, which is 2 seconds. So a ball which is thrown upwards with a speed of 10 meters per second takes 2 seconds to come back to its original position, right? If you want, you can remember this formula, but always remember the way we have derived it, right? Always remember that when something comes back to its position, it means that displacement is 0. So this is the more important thing here, that whenever something returns to its position, this event of returning in equation translates to displacement being 0, right? The next thing that we are interested in finding is the maximum height that this ball reached. So we are trying to find the maximum height to which this ball rose before it came back to its position. Now once again, we have an event of reaching the maximum height, but how do you convert that into a variable which can be put into the equation? Think about what happens at the highest point. How can we identify the highest point? Well, if you think about it, I'm sure you can figure it out that the highest point is the one where the ball stops momentarily, right? Because as long as it is moving, it is gaining height. But from gaining height to the point where it starts decreasing its height, there has to come a point where the ball stops momentarily, right? And that is the point which is the highest point in this trajectory, right? So the highest point can be identified by saying that at the highest point its speed would finally become 0. So we are basically looking at an interval where the ball started and where the ball stopped, right? So here it had a speed u with which we had thrown it up. This is the highest point where its final speed is 0. And at this point we have the maximum height, right? So we know the final speed, we know the initial speed is plus u, the initial velocity is plus u, we know that the acceleration is minus g, and we wish to find the height, which you can clearly see is simply equal to the displacement of this ball, right? So the maximum height translates to the displacement which is to be found, right? So once we know this, again looking at the set of parameters, we can see that clearly we would need the third equation to solve this problem, right? So let's get to that. The third equation tells us that v square minus u square is equal to 2as. Substituting values, you see that 0 minus u square is equal to 2 into minus g into. Now let's substitute h max, where h max means maximum height. Rearranging these terms, you can easily see that h max is equal to u square by 2g. So this u square by 2g basically gives you the height to which the ball will rise before it finally starts to fall. Right. So let's look at our previous example again. If this was the case, what do you think would be the maximum height attained by this ball? We can simply substitute values. U is given to be 10, so this becomes 10 squared by 2 into 10. Note that most of the time the value of gravity is taken as 10. So when you substitute values, this becomes 100 by 20, which is 5 meters. So this ball will rise to a height of 5 meters before it finally falls back to ground. Let's now look at another example. Let's say that a ball is thrown from the top of a tower which is 225 meters in height. Now the ball is thrown upwards with a speed of 20 meters per second. We are interested in finding the time after which this ball falls on the ground. So in this case, let's first once again try to list down the values that we know. First of all, it is given that the initial speed is 20 meters per second. Now, right now it is only speed because we have not yet decided on directions. Right. What else is known? We know that if the ball is thrown all the time while it's in the air, its acceleration would be acceleration due to gravity, which has a value of 10. We also know that it will point downwards. But for now, let's only record the values and then we'll substitute the sign according to our convention. Right. Is there anything else that we know of? Think about. When you throw the ball and it falls down, let's draw its approximate path. It will first go up and then come down like this. So, what do we know? We know that it has fallen through 225 meters. So, we can say that this distance is also the distance between the initial and the final position. And we know that the shortest distance between the initial and the final position by definition is the displacement. So, we also know that the displacement of this particle is 225 meters. Please pay attention to this because this is the most critical part of this problem. Often we get confused that the ball would first go up and then come down, and thus we start focusing on the distance that this ball is going to cover. But in our equations, we are only concerned with the displacement. And in the given situation, we can clearly see that after it falls on the ground, the total displacement would only be 225 meters. Right. So we have written down all the magnitudes. Now let's think about the direction. So once again, you can choose any direction to be positive. It could be upward or it could be downwards. Well, one way to think about it is that whichever direction has most of the variables aligned with it, you can take that direction as positive. Like in this case, I see that acceleration is downwards. The displacement also, I hope you can see, is pointing downwards because the direction of displacement is from the initial point towards the final point. So the displacement also points downwards. So we can, if we want, set the downward direction as positive because that will give us most of the variables as positive. Some people are more comfortable with keeping the upward direction positive throughout. You can also do that. But it sometimes helps if you spend some time and think about the direction which will give you most of the positive variables, right? So as per our convention, we see that acceleration due to gravity would be plus 10 because gravity is downwards and so is our positive direction. The displacement again is positive since it points downwards. What about initial velocity? The ball was thrown upwards, which is opposite to the direction we have taken positive, and hence the initial velocity is negative. Right. So we have these three variables and we are interested in finding the time after which it hits ground. So again, we have a set of parameters which are known or to be found out. Can you think of an equation which relates these four? Obviously, it is the second equation of motion which tells us that S is equal to ut plus at square by 2. Right. So now you only have to substitute values. First of all, displacement is 225. So you have 225 is equal to minus 20 into t plus acceleration due to gravity is 10. 10 by 2 becomes 5. So this is 5t square. So rearrange this, you get that 5t square minus 20t minus 225 is 0. I've taken 225 to the right hand side. Right. First of all, if you want to simplify this, you could divide it by 5 or you could directly get to the roots. I hope you know that for a quadratic equation of the form ax square plus bx plus c equal to 0, there are two solutions which are given by x is equal to minus b plus minus root of b square minus 4ac upon 2a. So let's apply this value to our given equation. We see that t, the solution to this equation, would be equal to minus b. Now b in our case is minus 20. So minus of minus 20 becomes plus 20. Plus minus square root of b square. So minus 20 when squared would give you 400. So b square minus 4ac. You can see that a is 5 and c is minus 225. So 5 into 225 gives you 1125, and 1125 into 4 would give you 4500. So this is minus 4500, and minus minus becomes plus, and in the denominator you have 2a, a being 5, you get 10. So t is equal to 20 plus minus 4500 plus 400 gives you 4900, the square root of which is 70. So we are left with 20 plus minus 70 divided by 10. So t is either 90 by 10, which is 9, or it is minus 50 by 10, which is minus 5. So the time cannot obviously have negative value. Hence, there is only one acceptable solution, that is t equal to 9. And so the ball will take 9 seconds to hit ground. Right. So we've got this solution, but once again I would like to remind you that the tricky part in this problem was to understand that even though the ball first goes up and then comes down, we are only concerned with the displacement of the ball. And the second important thing is keeping in mind the sign conventions. Right. So let's try another problem. Something similar, but this time we have one ball being thrown from the top of the tower downwards with a speed of, let's say, 10 meters per second, and the other ball is thrown upwards at a speed of 30 meters per second. So this is the second problem, where we have a tower from where two balls are being thrown, one from the top of the tower, the second from the foot of the tower. The first, which is being thrown downwards, has been thrown with a speed of 10 meters per second. The second has been thrown upwards with a speed of 30 meters per second. If it is given that the height of this tower is 400 meters, If the height is 400 meters, we are interested in finding the time after which these two balls collide. Right. So, in this case, once again, we have a similar situation, but please note that we have two different balls. Now, in such a case, when we have two different objects, you can have different sign conventions for both of them. I'll show you how. Let's first look at the ball which is thrown from the top. For that ball, we'll draw everything within this box. Right. So we have the ball being thrown down at 10 meters per second. We also know that it will have an acceleration downwards at 10 meters per second square. This is the acceleration due to gravity. Right. So for this ball, let's also assume that during this time interval, this ball falls through some height which we are going to call, let's give this ball the name A and this be B, then we are going to call its displacement as SA. So the height through which it falls, we'll call it SA. We see that all these variables are downwards. So for this, I'm going to take the downward direction as positive. Once I do that, I can say that the initial velocity is plus 10 meters per second, the acceleration is plus 10 meters per second square, and the displacement, which is SA, is also a positive value. Right. So the equation for the first ball becomes SA is equal to UT, which makes it 10T plus half AT square. So half into 10 makes it 5. So this is the equation for the first ball. Its displacement in terms of time is given by this equation. And we have written this equation by taking the downward direction as positive. Right. Let's come to the second ball. Now this ball is thrown upwards, so it has a speed upwards of 30. It has an acceleration downwards, which is 10 meters per second square, which is nothing but the acceleration due to gravity. And finally, it has an upward displacement, which we can label as SB. Right. But its displacement points upwards. Right. Okay. So now, for this case, since we have two variables upwards, let's take the upward direction as positive. So if we do that, notice that the acceleration is negative, but the initial velocity and the displacement are both positive. Right. So we will write the second equation for this ball. So we can say that SB, which is the displacement for this ball, which we have seen as positive, is equal to UT, U being 30 and positive, the first term becomes 30T. The second term, the acceleration is minus 10, and minus 10 by 2 becomes minus 5, so we have minus 5T square. So this is the equation for the second ball. Now, next comes, so we have three variables, two equations. I hope you know that if you have n equations, if you have n variables, you need n equations to solve them. So we need another equation to solve this problem. That equation comes from the physical event of these two colliding. So when these two collide, what happens? Let's look at it in this figure. So this is the point from where ball A started, and it moved downwards. Ball B started from the foot of this tower and it moved upwards. Right. So we see that at the point of collision, displacement of A plus displacement of B is actually equal to the total height of the tower. Right. So this gives us our third equation, that is SA plus SB is equal to the height, which is 225. Right? Right. So this also shows why I took the upward direction as positive for the second case, because then I get SB as positive. If I had taken a different convention, for instance, if I had taken downwards as positive for the second case, then I would have to subtract the equations. because then I would actually be assuming that the displacement is downwards. I want you to think about this case by yourself. Let's finish solving this problem the way we are doing. Right. So, SA and SB are known, and we know that their sum is 225. So once you add these equations, you simply get 40t is equal to 40t will give you 225. I'm sorry, we have taken the height of tower as 400. So this height is 400, and hence the time you get is 10 seconds. So the two balls will collide after 10 seconds. Right. So once you understand this, let me give you another interpretation of this, which involves a relative motion. Now we have not discussed relative motion in detail, so I'll just briefly mention this. You know that if two people are standing on the same vehicle which is moving with some speed, these two would find each other stationary, whereas a third person who is looking at these two people from the ground would say that both of them are moving. I hope you can imagine that. So this is the reason why we say that motion is not absolute, but it is always relative, which means that a thing is at rest or motion depends on who is watching that thing. There could be an observer who could say that this particular body is at rest, whereas some other observer would argue that it is in motion. Right. So in this case, what happens is that A and B both have the same acceleration downwards. Right. They both have an acceleration of 10 meter per second square, which is downwards. So since they both have the same acceleration downwards, if you ask A, he would say that B is not accelerating at all. This acceleration that we talk of will be the observation of someone who is standing on ground. So an observer who is on ground would say that both of these balls have an acceleration of 10 meter per second square downwards. But if you ask A, any observer who is moving with A, if you ask that observer about B, he would say that B does not have any acceleration because he himself has the same acceleration. Same is the case for an observer who moves with B. If you ask such an observer about A, he would say that A is not moving with any acceleration because this observer who is attached with B would not find any acceleration of A because he himself has the same acceleration. So, from such an observation where we are observing the entire event from an observer who moves with either A or B, we would say that the distance between these two is 400 meters. We would say that A moves downwards with 10, or rather, if A is recording this event, he would say that I am at rest. So I'm just making a passing mention of these things without going into details. I want you to think about it yourself and convince yourself. So if A is the observer, he would say that I am stationary and B is approaching me with a constant speed of 40 meters per second. And he would also say that B does not have any acceleration at all. Right. So you see that when this event is seen by an observer who moves with A, it becomes very, very simple. You have a simple distance and a constant speed with which B is moving. So as per A, this problem is very simple. There is a distance of 400 meters between them and B is coming towards him at 40 meters per second. So he simply says that distance divided by speed gives me the time, and hence 400 by 40 is 10 seconds. Right. So these two problems, I want you to solve these again by yourself and try to think about the results that you get. In the next session, we will look at problems involving gravity when the motion is two-dimensional. Thank you.